In this video, we're going to be talking about an important ore of silver, of lead, and sometimes of gold too. In fact, sometimes a nice indicator that gold is nearby. There have certainly been times that I've seen deposits, and I've even found gold there, where if you found galena there, you were likely to find gold. And that's our mineral today. Today we're going to talk all about galena. Well, galena is lead sulfide, and of course it is by far the most important ore of lead because that's mostly what it's made of. Now, it also is an important ore of silver because most galena, not all, but most galena has significant amounts of silver, sometimes up to about 0.5% of silver mixed into the galena, sometimes just as silver atoms in the galena crystal, or sometimes as little blobs of silver sulfide that are inside the galena crystal. So either way, it's silver and it's sulfide, and so it's an important ore of silver. Now, lead and galena have been used since ancient days. Early man found that you could turn this unusual mineral galena into lead with an ordinary fire. It could be smelted just with the carbon from wood and turned into metal. And so lead was one of the early metals discovered by man and used quite extensively. But also early on they discovered you could get a second metal out of the lead, and that's silver. And basically what you do is the ancients, what they did is a process of what we call cupellation, where the lead is oxidized and soaked into, in the old days they used bone ash. A lot of times today they use magnesium oxide powder that's been pressed into a mold. They use bone ash, and the lead oxide that was formed when you oxidize the lead soaked into the bone ash, but it left the silver behind. And that's a standard process for cupellation. And we'll talk a little bit more about home smelting and that kind of stuff a little bit later. But what the ancients did is, once they had the silver, okay, now they had the silver, but they had the lead in the form of oxide, so they again re-smelted the lead oxide from the crucible, from the cupellation crucible, and turned that back into lead metal. So they basically, oxidized it to get the silver out, and then were able to turn the oxide back into lead metal, and they would have purified lead metal and purified silver. So it was a pretty handy thing. So what is galena? Well, let's talk about the crystal forms, its hardness, cleavage, what galena looks like, how you can recognize it in the field, and we'll take a look at some photos and talk about the nature of galena as a mineral.
And here's a typical chunk of galena silver lead ore. The galena is the metallic, bright, dark gray colored material that runs through the middle of this. It often is massive like this, where there's not real obvious crystals, but the material here breaks down into cubic shapes, into squares that you can see easily looking at the ore. Sometimes galena will come in nice crystal forms like this, and when it does, these types of specimens have some real value to them. In this particular one, the white is calcite, the gold is chalcopyrite, and then of course the gray is the galena. More often than not, however, it just comes as kind of massive crystalline aggregates like this, where it's a whole bunch of crystals stuck together. But even in this, if you look closely at it, you can see the little square shapes of the cleavage fragments that it wants to break into cubes, even in the whole bunch of crystals that are all kind of aggregated together. This is a specimen of galena from a mine in Nevada, and there's an old adage that, and not just for Nevada but for elsewhere, that the smaller the crystals are of the galena, the more silver it's likely to carry. And while it sometimes works out that way, it's not a reliable indicator. You can have big crystal galena that has lots of silver, and you can have small crystal galena that is, has hardly any silver in it. So it's a generality and is sometimes true, but is not reliable. You actually need an assay. Here's a specimen of galena from the Cerro Gordo mine. It's spelled Sierra Gordo, but that's not correct. It's from the Cerro Gordo mines. And we're going to talk in this video a little bit more later about Cerro Gordo, and I'm hoping to go there this summer. But this is some galena from the mine there, and this was one of the minerals that was productive. And you can see the fairly good-sized crystals, and yet Cerro Gordo had good silver in the ore. Here's a specimen from the Darwin district in California, and it's partially oxidized. This specimen actually has a good amount of galena in it, but has other oxidized lead minerals like andesite, cerosite, and plumojarosite. And we'll get into the oxidation of galena into other lead minerals a little bit later on in this video.
Now, I mentioned that galena is basically a combination of atoms of lead and atoms of sulfur, and they basically go together in a 1-to-1 ratio. The lead is able to give the sulfur 2 electrons, and the sulfur wants 2 electrons, and so they're a good pair together. They match up pretty good. But, you know, sometimes in the crystal I mentioned, you can have silver, and sometimes you can even have some small amounts of gold. And so there is plenty of deposits of galena and lead and similar minerals where there's small amounts of gold actually dissolved into the galena crystal. And in some places where they recovered lead and recovered silver, they also recovered gold. Now, because the silver is so much more valuable than the lead, oftentimes when you have galena and you have significant silver in it, it turns out that the silver is actually worth more than the lead, because lead's a kind of a cheap metal, and to tell you the truth, in my lifetime, we've been moving more and more away from various uses of lead. They still use it for car batteries, but you know, we're pushing over, in some senses, over to some lithium phosphate type batteries, and then of course also used for bullets, but more and more you see bullets with iron and some other things in there. So lead is getting less and less use. It still has its uses. It's a great nuclear shield, so when they're dealing with radioactivity and radiation, you know, shields of thick layers of lead do a great job, better than any other mineral that you can have at a reasonable price. So lead is cheap, but the silver in it can be worth a lot more, and the gold in it can be pretty valuable too. So when you're doing any smelting or searching for galena and looking at that, always remember the silver and remember the gold, because there can be gold inside the crystals of galena. And like I say, we'll talk about it more in a little bit, but galena in some types of gold quartz veins that are valued principally for their gold, galena can occur as an accessory mineral and be a real good indicator that there is some gold nearby. Other elements that are commonly associated with galena include zinc and cadmium, sometimes arsenic and antimony, and sometimes bismuth and selenium, and copper too. And so there can be some of these minerals, and some of these minerals, some of the rare stuff like selenium and some other things like that, are actually recovered from smelting of galena processes. They're recovered in the flue gases. You know, it's required in any kind of, even in other countries, third world countries, you need to do some sort of dust collection from your smelting operation. And so when they're doing smelting, they recover the dust, and then the dust can contain some of these other metals like cadmium or selenium or things like that. And so the dust can actually be fairly valuable. So that's another important thing to know about the unusual mineral galena. Let's talk next about the types of deposits that are rich in lead that have a lot of galena in them. There's 3 main types. The first one is called SEDEX, or sedimentary exhalative, they basically form when hot metal-rich liquids somehow form underneath sediments in a water-filled basin, usually an ocean. and the material comes up through the sedimentary rocks that are on the bottom of the ocean floor, and as it contacts the cooler ocean waters, the cooler sediments, that precipitates in the sediments there. And these count for actually about half of the known lead reserves. The next is what's called a Mississippi Valley type. And of course, they're named after deposits of this type that are found in the Mississippi Valley of the United States. They're deep deposits and have only the most tenuous connection to any sort of deep igneous rock, hot rock, volcanic rocks and intrusive granitic rocks. Very tenuous. They're usually really deep, but they can extend over miles and miles. And there's still some of these being mined. Then the last that's of importance worldwide is called volcanogenic massive sulfides. And these, of course, have a direct connection to volcanic activity and to volcanic rocks that come near enough to the surface that they basically affect the rocks around them. And if you've ever heard of the black smokers that they have at the bottom of the ocean, you've seen pictures of these. If not, you can Google it and see them. They're weird looking, and they have some really weird forms of life that are usually around them. The black smoke that's coming out of these is sulfide minerals, and it can be rich in pyrite, it can be rich in copper, it can be rich in zinc or lead, silver, gold sometimes. And so there's some of these that are very lead rich that have a lot of galena in them. And so volcanogenic massive sulfides are a well-known type of gold or of lead deposit with galena. The last, we'll talk about a couple of other ones. Replacement type deposits. These are usually closely related to igneous intrusive rocks like granites and diorites and stuff like that. And then the last one that we'll talk about is skarns, also closely related to igneous intrusive rocks that are so close to limestones and stuff that they react with a limestone. Let's dig into the geology of these deposits and talk about, I'll show you some diagrams and we'll kind of dig into it and talk about the silver and the gold that's associated with these.
Here's a diagram of the sedimentary exhalative. Basically, it's on the ocean floor, it's on the surface or pretty much on the surface, and a feeder zone comes up to the surface. Now, actually, both the blue and the gray are water. The upper blue is oxygenated water, and then basically the gray below it is oxygen-free water that has hydrogen sulfide in it. Anyway, this allows the material that comes up from the feeder zone to basically, when it hits the cooler water, to precipitate out sulfides. And it's similar to the volcanogenic massive sulfide, VMS, that we'll look at. And then on the right, there's picture A of the sulfides. They're kind of bedded and even deformed and just showing layers going up and down of similar sulfides. This is a diagram of the Mississippi Valley type lead zinc deposits. These are formed very deep underneath limestone, and there is somewhere a heat source, but often these are never found, and it's not really known where the heat and mineralized fluids are coming from, but they come up and deposit underneath beds of limestone. And generally speaking, like I say, I mark this as lead zinc. These deposits have very little silver in them for the most part. And this is a diagram of the volcanogenic massive sulfide type. On the right, you can see basically there's some magmatic heat source down below. The metals are leached by the seawater circulating through fractures in the rock, and then they're driven up by the heat. And when they come out, they are instantly cooled by the ocean water around them and form this black smoke of mineral sulfides. And you can see the pictures of these black smokers there on the left. This is another diagram of the black smoker volcanogenic massive sulfide VMS type deposits. You can see the red down below is magma, and the heat is rising up, and it's creating these black smokers along a fault zone, and they often occur in groups. But this is conceptually the circulation of the seawater drives the formation of these types of deposits. Here's the carbonate replacement type deposits. This is one of the lesser sources of lead, but historically it's been a very important source. You have intrusive rock, some sort of granitic type rock below, providing heat and some mineralizing fluids. And as the fluids rise up, and these things are in carbonate beds, in limestone beds, along faults and along bedding planes, you'll get this replacement of the basically the limestone with minerals, vein minerals, quartz and calcite and galena and sphalerite and other minerals. And again, these often have good silver values, and some of them even have really good gold values as well. And this is the skarn type mineralization. You can see there's a body of granitic rock, the pluton, that's there. And it's very similar in an idea anyway to the carbonate replacement, except that skarns form real close to the pluton. And so the replacement ones are formed at a distance and at cooler temperatures, whereas the skarns are formed real close to the heat source and at higher temperatures because of that. And so you get different minerals. In skarns, you get lots of garnet and epidote and things like that, whereas you just don't see that in the replacement type of deposits.
Next, I want to talk about galena as a gold indicator. And there's a number of places, more of them in the mother lode country type of places, where you have orogenic type of deposits, where galena is a minor mineral that's associated with pyrite and other things. But in some of these where, and I've been to some of these deposits that I've detected some of the old mine dumps, where you do have galena in the vein, because it's not a major part of the vein, and then these veins are never any big source of lead or galena. But where you do have galena formed in the vein, it's almost always where you have gold, either right there or very nearby. And in fact, I have a specimen. I'm going to see if I can find it, and I want to show it to you. So I got this off a dump, and it has some gold in it.
Well, I couldn't find the specimen I was looking for, but this is another picture of some bright gold, and the dark gray there is galena, the colorless or white is quartz, and they are associated in some. I know that in the Grass Valley district that rich pockets of high-grade ore were associated with also galena being there.
Next, I want to talk about associated minerals that go, like I said, galena as a gold indicator, but there's also minerals that are commonly found with galena, and it includes things like pyrite, of course, but also very commonly sphalerite, which is a zinc sulfide, zinc mineral. So, lead, silver, zinc deposits of various types are very common. And then in addition to that, like I say, chalcopyrite, sometimes arsenopyrite, like I say, chalcopyrite I mentioned. And depending on how much silver is in the deposit, you can have various silver minerals. Up at Virginia City, which is not very far from here, a very famous epithermal type gold-silver deposit. There's quite a bit of galena and sphalerite, which is the zinc sulfide, that are associated with various silver minerals. And when you find the silver minerals, invariably you're going to find the lead and the zinc associated with them. So you may find polybasite or stephanite or just plain old argentite, acanthite, silver sulfide, and associated with them is these base metals. So they're an indicator. And also, when there's gold associated with them too. So this is another thing where gold is associated with these types of minerals, where in the vein, it's, Virginia City was a big silver and gold deposit, and even though there was lots of lead and zinc that came out in the ore, very little of it was ever recovered. It was just kind of let go, and because the miners wanted the silver and the gold. So it's associated with a number of different kinds of minerals. Let me show you some pictures and we'll talk more about it.
On this specimen, the darker colored cubic mineral is galena, of course, but the purple cubic mineral is fluorite. The white is calcite. And as far as gangue minerals, calcite and fluorite are two of the most common minerals that galena is associated with. This specimen has nice gray cubes of galena on a darker mineral, and the darker mineral is sphalerite. This is a zinc sulfide, and it's the other common ore mineral. That's why they're often called lead-zinc deposits, because the ore minerals are galena, lead sulfide, and sphalerite, zinc sulfide. I did show you this specimen a little earlier with the gray galena. The gold color is chalcopyrite, so copper can be associated with these deposits as well. The other sulfide very commonly found with these deposits is pyrite, just standard iron pyrite that comes in the cubic crystals. It's very common.
Next, let's talk about the oxidation of galena. Now, galena as a mineral is very susceptible to attack by water and oxygen from the air. It basically oxidizes the sulfur in the galena to sulfate or some other mineral, and then oxidizes the lead to some other mineral. And usually the two most common minerals that galena gets oxidized to are cerusite, which is a lead carbonate, and anglesite, which is a lead sulfate. And so those two are pretty common. And the silver in them can't go into these other minerals. So you have silver that's inside the galena, but when you oxidize the galena, the silver has to go someplace else. It can't go into the cerusite or the anglesite or any of the other silver lead minerals that form from the oxidation of galena. So the silver has to go someplace else. And usually the silver either becomes a silver chloride or metallic silver. This is the main way that metallic silver is formed. And very few primary deposits contain metallic silver. Almost all the silver is produced by secondary processes of oxidation. But let's take a look at the different minerals and the associated minerals. We'll even look a little bit at some of the other minerals that go with it, like sphalerite, what happens to the sphalerite. And we'll talk about oxidation, because actually the oxidation process can enrich the deposit and make it richer. So let's talk about how that works and how oxidation works in galena. And let me show you some pictures.
This specimen is a great illustration of the oxidation process. At one time, this whole chunk would have been a big chunk of galena, but you can see there's kind of a heart of galena in the middle, but it's surrounded by this nondescript brown rock, brown gray. And this is cerusite. It was all galena, and the outer part has been oxidized by exposure to air and water, water percolating down from the surface, and it attacked the galena and converted it to cerusite. But the heart of the thing, that's the center of the mass of galena, is still galena. But it shows how the process works from the outside in. Cerusite can be massive, like the specimen I just showed you, the brown gray, but it also can form crystals. And in fact, I've even seen clear, colorless crystals of cerusite. The other mineral that the galena commonly turns into by weathering is this anglesite, and this is a specimen with clear crystals of it. Here's another interesting specimen that was once all galena, but now none of it's galena. The white tan kind of color on the right is anglesite. It's the lead sulfate. But the darker gray is not actually galena or anything. It's cerargyrite, which is silver chloride. And so, like I said, the silver that's in the galena has to go someplace. It can't become part of the minerals like the cerusite or the anglesite. It has to form its own separate mineral because it can't fit into the crystal structure. Sometimes lead combines with some rarer things in the system, and you get beautiful colored crystals of different things. This is a lead phosphate. It's pyromorphite. When the lead combines with molybdenum, you get this beautiful wolfenite, another mineral that's highly prized as specimen. If there's any chromium in the system, you might get this unusual orange mineral, which is a lead chromate. The sphalerite that's in your system that gets oxidized can't combine with the lead, but it forms this mineral, which is smithsonite, a zinc carbonate.
Now, one of the things about oxidation of these minerals is that it makes them open to various leachings, and the silver gets locked inside the galena, and it's hard to get it out apart from smelting. But once it oxidizes, like I say, the silver has to go someplace else, and it's not locked within the galena, and the galena becomes something else, and the silver becomes something else too. So one of the things that happens with this is it opens up these deposits to being tested by leaching. And I'm going to do some stuff. I've done some initial tests leaching sulfides. It didn't work out so great, but I'm going to do some tests leaching oxidized ore, and I expect that the results will be a lot better in leaching the oxidized ore. But we're going to do these tests and take a look at it. One of the things that I'm hoping to do this summer is to get up to a place called Cerro Gordo, which is a replacement type lead, zinc, silver deposit in California, in the mountains east of the Sierra Nevada. Anyway, I'm hoping to get up there and take some samples, talk to the guy that owns the property, and maybe do some testing to see if I can't leach some of the silver. He's been doing some home level smelting, and it's a lot of work to collect the galena, smelt it, separate the silver out, and then get, the leaching would be a lot simpler because you can just leave the lead where it is and take the silver. And that deposit, it has gold, but it's really small amounts, and for the most part, really small amounts, and won't be worth really going after much of the gold. But getting the silver out could be a really interesting experiment and make getting silver out of the dumps at Cerro Gordo, because the dumps are going to have silver in them from material that the miners couldn't afford to smelt. So they're gonna have some silver in them, and I'm hoping to demonstrate that for you guys sometime this summer. Finally, we'll talk about the home smelting of lead and silver. I've got some galena, and I've got some concentrated silver minerals from up at Virginia City, and of course they have some gold in them too, and I'm hoping to develop that and do some pours. Right now it's actually snowing outside, and there's snow on the ground. Not good for doing an outdoor furnace and doing some home smelting. But home smelting is very possible, small scale smelting, and I want to do some of that and demonstrate some of that for you guys. And I think it'll be interesting, so you can look forward to that in an upcoming video. Now, whether you're looking for galena and silver, or whether you're looking at galena as an indicator for gold, or trying to get the gold out of, because there's some galena deposits that do have significant gold in them, and there were significant gold producers. So no matter what you're looking for, the more you know about geology and prospecting and that kind of stuff, the more success you're going to have. And I've written a book where I took my experience, my degree in mine engineering, and my experience working in the mining industry, and being a prospector on my own, and I put it into a book called Fistful of Gold, because that's what I want you to be able to go out and find, is some fistful of gold. And I'm going to tell you a little bit more about my book right now. This is my book, Fistful of Gold. It's an encyclopedia of everything you need to know to go out and find gold for yourself. It distills down my 45 years of experience out in the field prospecting, as well as my degree in mine engineering. It's, like I say, an encyclopedia. There's a lot to it. It's over 250,000 words long, hundreds of pages with hundreds of illustrations, teaching you what you need to know about geology, about mining districts, about techniques of finding gold. It covers metal detectors, sluicing, panning, dry washing, high bankers, you name it, it's covered in there. It talks some about platinum and diamonds, but it's mostly about gold, because gold is more widespread. It is not so much a book about where to find gold, but a book about how to find gold. Because even if you have a location where gold was mined in the past and you go out there, well, where should you look to be successful in your prospecting, to find the gold that's there? This is the book that's going to tell you that information. I spent most of 10 years writing this book, so I thought a long time about it. It's got, like I say, lots of information and lots of illustrations, and I've had results from people who bought it. It's available on Amazon, but I recommend buying it through High Plains Prospectors, and I'll put a link in the description for buying this book through them. They have a better price than Amazon, and I have a special deal that I'll tell you a little bit more about, where you can get a 5% discount from the price even with that. On Amazon, the book rates a 4.7 out of 5, which means that of all the people that have bought it, they've been really highly satisfied, and I think you, if you buy my book, will be just as highly satisfied as well. Now let's talk a little bit more about High Plains Prospectors. They're a prospecting shop, a mail order prospecting shop that I've partnered with. The deal is that I can get you a 5% discount, a coupon code, and I'm going to put the code to that right here. It's just Chris Ralph, all caps with no space between Chris and Ralph. You put that in there as a discount code, and you'll get 5% off their already really good prices. I think it's a great deal where you win by getting a discount. I get a little percentage of that, and they get new business. So if you need prospecting supplies, High Plains is really the way to go. And I'll put information, like I say, in the description more about how you can work with them, because I'm working with them. They really are great guys, a great company. For even more information, I also have a website, and I'm going to show you my webpage and talk a little bit more about that right now.
This is my webpage. It's located at NevadaOutbackGems.com. You can Google it, or I have a link down in the description below. But there's lots of information here, miscellaneous stuff, pictures, some historic information as well, stories. It's got a lot of great fun stuff. You'll probably be interested in it.
Now, on all of my YouTube videos, I encourage you guys to ask questions. If you have thoughts, comments, suggestions for things that I ought to look at in my videos, things that you want to find out more about, and I answer 100% of my questions. There's not very many YouTubers out there that answer 100% of their questions. I'm one of the few. And so I will do my best to answer what you have. I mean, I only can write so much. Sometimes the answer is something where I'm going to recommend that you buy the book and read about it. I also ask that you subscribe to my channel, click the bell notification so that every time I come out with a new video, you'll be able to watch it. And like I say, I cover a huge amount of topics. I also have 250 videos that I've already done, and so you can go back through my catalog of videos on YouTube. I'm sure there'll be many videos there that you'll want to take a look at, especially if you have any interest in gold or platinum, diamonds, gemstones, geology, and that sort of stuff. My YouTube site is going to be right up your alley. So I'll see you again real soon. We'll be out in the field and back in the office at the whiteboard, and whether we're looking at gold or platinum, diamonds, gemstones, or other interesting geology, it's going to be fun. You're going to enjoy it, and we'll see you again real soon.